Hi, I'm Chris Romanchock, and I'll be speaking tonight on the impacts of Agent Orange manufacture on the city of Niagara Falls, New York. I'm a public school teacher and adjunct at Alfred University in the western part of New York State, and my interests include the communications infrastructure and industrial capacity of America during the Cold War. So, this is a pretty familiar picture for those of us who, are interested in the Vietnam War. Agent Orange was a herbicide that was sprayed by most famously sprayed by the United States military on Vietnam, mostly South Vietnam, at the behest of the South Vietnamese government to deny the guerrillas their cover. The impact of Agent Orange on the Vietnam conflict is certainly debatable, whether it was an effective use of a weapon or whether it was in fact chemical warfare in violation of international treaty. Those are all things that historians argue about. What they don't tend to pay attention to is the impact on the manufacture of Agent Orange back home. So this is my hometown, Niagara Falls, New York. Assume some of you have visited it. Beautiful town. But Niagara Falls is sort of stuck on the horns of a dilemma. On one hand, you've got one of the natural wonders of the world in the heart of the city, that'd be the falls. And boy, they are pretty. On the other hand, you've got what appeared, at least in the 19th century, to be a limitless source of energy. And before, the widespread adoption of efficient oil or certainly nuclear power, that limitless supply of energy led a lot of people to come up with a lot of different schemes and plans to tap into it and use it to forge futures. One of the futures that actually happened for us, you can see to the background here. I don't think that I can get I'm not smart enough to get a pointer, but if you look at the skyline, you'll see several small smokestacks, a couple of puffs of smoke coming up there. That represents a stretch of the Niagara River coastline that is really populated by chemical plants. But I guess I want to dispel something. First of all, my title says that I'm examining the impact of Agent Orange manufacture on Niagara Falls. And officially speaking, there was none. No Agent Orange was manufactured in Niagara Falls. Agent Orange was manufactured by 9 chemical companies, pretty spread evenly across the country, 2 in New Jersey, 1 in Ohio, 2 in Missouri, and then a couple sprinkled here and there. The big one, of course, in Midland, Michigan, that being Dow. Agent Orange, by the way, just a sort of a point of fact, it wasn't orange. It was a clear to brown viscous liquid. It was called Agent Orange because of the band painted on the drums. You can see this in this Army Depot picture from down in Florida. Agent Orange was one of the rainbow herbicides that the Army Air Force commissioned during World War II as a potential advantage to weapon to use against the Japanese. Niagara Falls, however, was deeply involved in the manufacture. They just didn't make the Agent Orange itself. Instead, they made precursor chemicals that are going to be blended by other companies into the Agent Orange. The city was so deeply involved because of that natural positioning of it. It had grown up as a real center of the chemical industry because of 3 factors. One was that limitless power, especially the power once harnessed in 1895 by Tesla's groundbreaking alternating current generator installed in the city's Sholkoff power plant. This was really, as far as I can tell, the first easy availability of commercial quantities of electricity. Other than thermal plants, Niagara Falls was it. This was where you started. And it also had access to salt and, of course, the water from the river. We're going to focus in on a chemical company called Hooker Electrochemical. Hooker Electrochemical Company began in Niagara Falls in 1903 using something called the Townsend process that was invented by a guy named Townsend, whimsical, but also Elmer Sperry, the guy who invented the gyroscope, beloved children's toy and intercontinental ballistic guidance system element. These 2 guys came up with a method to manufacture lye, caustic soda, using an incredible amount of electricity and generating as byproducts hydrogen gas and chlorine. These two byproducts are going to be what most of our story is about. The lye, the caustic soda, is going to have tons of industrial applications, but they're going to be relatively straightforward, and Hooker will sell it by the tank car load in their sort of trademark orange and black tank cars all over the country. But early on, the hydrogen and the chlorine were just wasted byproducts. They'd burn the hydrogen off and they would chlorinate lime and sell it off to people who made more complicated chemical compounds from the chlorinated lime. Effectively, the lime stabilized it. Often those companies were in Germany, where most of the advanced chemical engineering in the world was before World War I. World War I, of course, upset that trade more than a little bit, but that's okay. Hooker found a ready market for that chlorine in the form of picric acid, which is going to be, by volume, I believe, the largest, the most common explosive used on the Western Front. Picric acid, it was that the tanker that blew up Halifax was carrying. I don't know if any of that came from Hooker, but it's certainly plausible. I can't speak to that, I guess. A quick map of the city of Niagara Falls. When you are standing in some parts of Niagara Falls, Canada is north and west and south of you. Sort of a unique position there. The falls themselves are in the bottom left-hand corner. The area in light blue is the Hooker chemical plant. We saw that on the skyline of that picture of the falls. That's a 60-acre lot located about 2.5, 3 miles from Niagara Falls. The area in orange to the bottom and right, which works out to the sort of due south of the Hooker plant, is the S area dump that I'll be talking about. Underneath your Zoom face boxes, so probably invisible, is Love Canal. That's the most famous Hooker dump. And at the south end of that is, in purple, is the slightly less famous 102nd Street dump. In blue is the Hyde Park dump. All of these dumps are, or pardon me, that's Necco Park. I misspoke. Yellow is Hyde Park. Blue is the Necco Park CMS dump. These dumps all map out the border of the city of Niagara Falls at various points during its development. And all of these dumps were used by Hooker, but not all of these dumps were used by Hooker in the Vietnam War era during when Operation Ranch Hand spraying those herbicides was in operation. It's a close-up view of Hooker's lot on Buffalo Avenue, and also a close-up view of the S area as it currently is. If you look closely, you'll see many of the buildings on the Hooker lot have been torn down. The plant recently announced that they were closing, so this plant is no more, and much of it has been destroyed, packed up, and buried in landfills. A lot of it bearing some very interesting Cold War history, even going back into the Manhattan Project era. It's a picture of the Hooker factory. This has got to be after 1963 because of the highway running along the river there and the water intake buildings that you can see, the large block twin buildings there right on the waterfront. But I can't place the date on this photograph exactly. The plant at its peak was substantially more built up than this. The side of the photograph, the right-hand side of your photograph there, where it seems like it's mostly empty field, that's all going to be built into processing facilities. All right, well, Hooker ends up making use of those byproducts to manufacture halogenated phenols. We could go into the chemistry of what we're doing here, but effectively we're going to take phenol, which, if you're familiar with sort of Civil War medicine, is your carbolic acid, and we're going to drop chlorine into it in various spots along the ring that makes up the phenol. Halogenated phenols are going to be a super important product for Hooker because it's going to consume, again, that otherwise worthless byproduct that they don't have. They're also going to halogenate benzene. Benzene and phenol are closely analogous, the difference being that phenol has a hydroxide group hanging off of it, whereas benzene only has an oxygen. Trichlorophenol, which is going to be phenol with 3 chlorine atoms on it, is the company's highest volume product after World War II. This is a big deal for them. This is what most of their facility is going to be dedicated to. And it turns out that trichlorophenol, I'll abbreviate it to TCP moving forward, is a precursor to one of the 2 herbicides that make up Agent Orange. Agent Orange being a blend of two different herbicides that act very similar in very similar ways on plants, but in slightly different at slightly different speeds and in slightly different ways depending on whether the plant is a woody plant or a broadleaf green plant. Hooker also manufactured TCB, trichlorobenzene, although in smaller quantities. That was a precursor to the other herbicide in Agent Orange. So I feel like my point that Hooker manufactured these precursor chemicals is relatively strongly made. I can link them directly to Dow, but I think that's outside of the scope of this paper. I want to talk more about what happened to Niagara Falls as a result of this. The picture we're looking at here is it's a still designed for purifying trichlorophenol. Trichlorophenol, when it comes out of the reactor where the chlorine is bonded to the phenol ring structure, contains impurities. Among those impurities is trichlorodibenzoparadioxin, or TCDD. This is perhaps the scariest thing that I've ever read about. Dioxins are pretty terrifying. They are vituperatively toxic to human life, and that in astonishingly small quantities. And they are an inevitable byproduct of halogenation. So as we put those chlorine atoms on the phenol, we generate this TCDD in greater or lesser quantities, it turns out, depending on the temperature and pressure at which we make the halogenated phenols. It was present in the TCP manufactured by Hooker and sold to Dow Chemical Company. Again, I'm certainly happy to share with you the letters back and forth between Dow and Hooker about this problem once it was discovered. And it is abundantly present in that still that we're looking at right now. The still was a constant process bubble plate still, which meant that fresh phenol was fed into the bottom of the still and distilled, and then pure phenol was collected off the still head. This meant that there was a constant reservoir of this material in the bottom subjected to high temperature and pressure, and these are the conditions that lead to the formation of these dioxins, especially that particularly nasty one, 3,4,5,7 dioxin. Now, a good deal of the still bottoms, the material from the still that was never going to cross the still head, would be pumped out of the still and then taken to the southwestern end of their plant and dumped in what they called the S area. The S area corresponds to an address in the Hooker plant's internal address system. The S area is going to be used by Hooker for disposing TCP waste, especially still bottoms, from 1947 to 1975. A lawsuit that Hooker ended up losing indicated that they had dumped something around 63,000 tons of materials there, unspecified materials, but definitely 200 tons of still bottoms. That's a lot of this stuff, which contained a lot of dioxin. Most of these still bottoms were in the form of non-aqueous phase liquids, or NAPLs. This is the fancy word for sludge. And the sludge dumped in the S area is going to be richly contaminated with these dioxins. Just for quick comparison, the spraying of Agent Orange and other rainbow herbicides on Vietnam dumped about 328 pounds of dioxin on that country, based on the Air Force's guesswork following the incineration of all the surplus Agent Orange at the end of that program. We suspect that there's about a ton of dioxin in the S area. That's a substantial quantity of this material. It's a picture of the S area. For whatever reason, people don't take a ton of photographs of working chemical dumps, but this is a picture of the remediation project where they attempted to secure the materials that were there from creeping into the river. Not a great picture or a particularly interesting picture, but I do want you to look at the back of the photograph where you will see the Niagara Falls drinking water treatment plant. The S area was located 30 feet from the Niagara Falls drinking water treatment plant, which a little too close for comfort for me, especially given that the sludge, the NaPLs that were dumped in the S area, did not stay there. The S area is built on top of riprap, boulders, limestone boulders removed from the tunnels that provide water to the Niagara Mohawk power project. In the back of this picture, again showing the excavation of the industrial water intake that proved to be a migratory route for these sludges. You can see the gate, this building in the background. It's a sort of gray square with black vertical lines on it. That encloses the gate that meters the amount of water that goes from the Niagara River and into the reservoir, feeding the power project during the day when they turn the falls on for tourists. So the tunnels run 8 miles across the city, and digging them produced a ton of material, well, several tons of material, hundreds of tons of material, which were used as landfill to build the edge of the river out. And the S area sits on top of that. These large limestone boulders sort of predictably proved to be quite permeable to sludges and anything you dumped on top of them. Those NaPLs, as well as the detergents used to clean equipment, perked down through those boulders into bedrock and then migrated off-site, heading northeast towards Niagara Gorge and, importantly, towards Canada. Now, this migration was noticed, not when it should have been before it happened, but when the sludges turned up in the adjacent Niagara Falls city drinking water intake, which created some furor in the early part of the 1980s. They are supposed to be non-aqueous, thus non-dissolvable in water, but it was still worrisome when dangerous toxic sludge ended up in people's drinking water potentially. The lawsuit led to Hooker, which had become Occidental after the Love Canal disaster, led to Occidental remediating the site and attempting to prevent the migration of materials. This is the site as it is today. On the left-hand side, you've got the S area outlined in blue, a sort of waste field outlined in orange where the old water treatment plant used to sit, and the new water treatment plant in red. At the very bottom of the left-hand picture, you'll see a shadow in the river. That is the Niagara Falls drinking water intake. And I wanted to call your attention with this blown up version of the S area. Each one of those little gray squares that you can see along the southern border of the S area, which is the bottom of your picture, and all sprinkled throughout, are guard wells, which are pressurized. There's a couple of them in this photograph. These are pressurized and pumping water off of the bedrock layer up and into tanks that is going to be disposed of afterwards. Now, this is the Society for Industrial Archaeology, and I got to say that I was sort of profoundly puzzled by how to do an archaeological survey of something that was designed both to be invisible and where digging was most inadvisable, right? This is a midden site, but we sort of know what's there, and we definitely know that we don't want it dug up or cataloged. I think that it's an interesting challenge, and it's one that I'm not sure that I met. I don't know exactly what the archaeology of waste is in this case. I do want to note that Ariel Aberg-Rigger calls the sort of cosmetic redo that we give these sites bad impersonations of nature. And I thought that quote was so good that I just had to share it with you. And I'll end with a quick coda. I said that the material pumped out of the bedrock layer had to be disposed of. And here it is being disposed of. The material impounded from the S area and other toxic waste dumps around Niagara Falls is trucked over to the area that was outlined in blue on my first map, the Seacoast or Chemical Waste Service dump. It's one of the few dumps on the East Coast that will take hazardous waste, and it's dumped there. It's trucked fewer than, from the S area, I'm going to guess it's about 2 miles, and dumped there. This modern dump, we're assured, is built to the most stringent modern standards and as safe as is currently technically feasible. This is cold comfort to me, anyways, given that the S area was in its day as well. So I realized that that was a whirlwind tour, and I thank you for going on it with me.